Alright, so for this video, we're going to get at it here. We're going to fill out these notes. So first off, a couple little concepts review topics are simple ones here. So here we go. Slope-intercept form, which is y equals mx plus b, where m is your slope, b is your y-intercept. So you need to know what those two things are. If not, go check out one of my videos where I talk about MB graphing a line. The next thing you have are standard form conversions. Or you're just going to use standard form properties of equality, and I'll demonstrate a little bit later. But standard form, that equation is ax plus by equals c. If you want to know more about standard form, then again, I got a video on that. You should go ahead and watch. But if you convert that to graphing, you're going to be doing the same process over and over again to end up with what y equals. And the way you get that is by taking the opposite of a. So you'll end up creating these fractions over and over again. The numerator of the x term will always be the opposite of a divided by what your value of b is. And your constant is always going to be found by taking c and dividing it by b. So, you know, if you're looking for a shortcut to do some of these problems to get through a little quicker, there you go. All right, so the last thing we're going to talk about is this change of inequality sign rule. So basically, the best way to demonstrate this is to show it on model it on a number line, but let's talk about some things. We have to set up some parameters very quickly. So the first parameter is this, that if I claim that some letter or some value of A is greater than some value of B, then what clearly is going to be true is going to be this, that if I take the opposite of B, that it is going to be less than the opposite of A is going to be less than the opposite of B. So what I did to create the opposite of A is I multiplied it by -1. Multiplied that B by -1, it gave me the opposite value. Well, simultaneously, if you notice that if I multiplied something by a negative, what did it do to the inequality? It switched the inequality, right? It took my inequality from being greater than. So the logic behind this is that if you multiply by a -1, it automatically is going to take your value that you're claiming to be greater than. When you multiply it by a -1, it then makes it less than. So that's the logic behind it. There's nothing more than that. And to show this on a number line very quickly, okay, if I were on a number line, it's just this. So just to show you this very quickly, is that if I had this point, and we'll label this as point A, right? So we'll call this B, sorry, hold up, we'll keep our model correct. I'm telling you that A is greater than B, so A is going to be the right of B. And just to model this on a number line very quickly, if I take the opposite of number, it's not saying it's farther away from 0, it's just saying it's the same distance away from 0, but on the opposite side of 0. So go to the opposite side of the 0, plot my value there, okay, and that's the opposite of A. Okay, go to my B, plot that point on the opposite side of 0, and that's now a negative B, right, because it's on the opposite side. And if you notice here, there you go, I've just proven that my opposite of my A is going to be less than whatever my B was, because it's to the left of it. So that's it, that's the simple concept. So basically what you need to get out of that is that simple rule that if I multiply or divide by a negative, that it flips the inequality for that reason, okay? So there's the logic behind it, so I hope that helps a little bit. So let's get into some problems here and get moving, all right? So let's do an example of converting the equation from standard form. So first thing, we're just going to use the properties of solving an inequality. So here we go. So we'll start off with this problem of 3x plus 5y is equivalent to -20, and yes, I'm using equalities for now. But here we go. So using properties of equality, so I'm going to go the addition of opposites. So the addition of opposites would be, if that's a +3, this is -3x. That makes 0. Well, if I'm in an equation, then I must do what I do to one side to the other side. So -3x. And what I'm now left with is that 5y equals -3x minus 20. The last step is divide by the coefficient of y, divide by the coefficient of y. Now the important thing here is that if I divide one piece, I must divide all pieces of that. Okay, so that's important. So I get my final answer of y equals -3/5 x minus 4. So now this is review, so I am going through it kind of quick. So it's meant to be a review piece, just a quick little refresher. Now, if I'm using the conversion formulas, all right, so the conversion formula will state that I'll just take this equation and make it a y equals, and all I'm going to do is take the opposite of that number, which is -3, and divide it by the coefficient of y, so 5, and that's now the coefficient of x. And then my constant, okay, so I'm going to put plus, my constant will be the number that's here, which is c, so it's c divided by the coefficient of y, which is 5. So now it's just a matter of simplifying, and I get y equals negative 3/5 x minus 4. So notice I get the same thing that I had before. So that's just, again, just demonstrating the conversion formula for you. So if it makes sense, then it's a great, powerful little thing to know. If it doesn't, stick with the properties of equality. All right, so graphing linear inequalities. A couple things we need to know, a couple things we need to review. First thing is greater than or equal to means that we are going to be shading up. Okay, so we shade up from our line. So if I have my line, I'm shading above the line. All right, so that's an important piece. The next one is if I have a less than or equal to, then I'm shading below my line. All right, so that's your basic review for graphing linear inequalities. So let's go ahead and graph this linear inequality that we have in front of us. So if I'm using the conversion formula, which is what I'm a fan of because I've done this forever, the only thing we need to pay attention to now that it's an inequality, okay, is going to be the fact that if y is negative. So now all we need to pay attention to is if that y is negative, then that inequality flips. So y is negative, so this is going to be a greater than, so y is greater than. So then we just go ahead and use our formula as normal, so conversion formula. So the conversion formula in an inequality just needs to flip the inequality if the y is negative. So now here we go. Take the opposite of this, which is negative 6, divide it by the current coefficient, which is negative 4. That will be my coefficient of x, and then I say plus, and I will take my c, which is 24, and I will divide that also by the coefficient of y, which is negative 4. And now it's just a matter of going ahead and cleaning that up. So negative 6 over negative 4 is 3/2 x, and 24 divided by negative 4 is negative 6. So there we go. I've now got it. I've converted it, and all I'm going to do now is graph it. So I'm basically looking at this, and I'm going to note a couple things. So I'm going to visually get my information down on this paper before I go ahead and graph. And the first thing I'm going to note is that I am totally shading up because it is a greater than. So the next thing I'm going to note is that this is a dashed line. It is not a solid line, it's a dashed line because it's not equal to. And the last thing I'm going to note is my slope. And my slope is going to be 3/2. Well, they're both positive, so 3/2, right? Slope is your rise over your run. It is your change in y's over your change in x's. Well, y's change by going up and down, and x's change by going left and right. So the top number is your change in y's, the bottom number is your change in x. So my 3 is a change in y, which is positive, which means I go up 3 values. Okay, and my change in x is a positive 2, which means I go right 2 values. So now all I need to do is work my way backwards. So what I'm going to do is go ahead and get my starting point, and then I'm going to do this information, dash the line, and shade above. So here we go. My starting point's at negative 6, so I use an open circle because it's the dashed line. And now I'm going to go up 3, 1, 2, 3 from there, to the right 2, put another open circle, up 1, 2, 3, over 2, put another open circle. I am now going to connect those things with a dashed line. So there's my dashed line. And the last bit I'm going to remember is I'm going to shade up. So I'm going to go ahead and I'm going to put a little up arrow there very quickly, and then I'm going to go ahead and come back in here, and what I'm going to do is simply shade directly above this line. All right. So I went through that as quick as I possibly could, but those are just some review topics and basic main concepts that there are to go ahead and before it. So okay, let's get on to that next example. I'm saying now what we're going to do is I'm going to take that information from our previous video and get it all together. Okay, so we're going to put it all together here. All right. So putting everything together is the challenging part when you're talking about systems of linear inequalities. So first off, you need to make sure that you put them both in graphing form. Neither of them are in graphing form. So after we're done graphing this, I have some extra follow-up questions that we're going to answer just to really build and solidify this idea of what it means to be a solution to these systems, because linear inequalities don't hold the same solution properties that equalities do, okay? Because equalities require you to be strictly on their line, where inequalities allow you to jump off the line, all right? So anyhow, let's go ahead and convert these things into slope-intercept form. So I'm going to move over here and do the top one to the left, okay? And then I'm going to do the bottom one over to the right. And the reason I'm doing that is because I want to separate them out. They are two separate distinct lines, so I'm going to graph them separately by themselves, one at a time, and then I will come back in and I will do the other one through. All right, so here we go. So the first one I'm going to convert starts off with x plus y is less than negative 2. So I need to make this into y is less than or greater than or equal to, right? this mx plus b. So the way I do that is I take this value, which is a positive x, and I make positive x by utilizing the addition property of opposites, so negative x, right? And this should look familiar to you as the elimination property, right? You're taking opposites, and when you have two opposites, they cancel out to make 0. So I must do that on the other side because I'm the one who put the negative x in there, so I throw a negative x in there, and now I get y is less than negative x minus 2. Now, I am not going to move on to the other equation. I'm not going to solve that one. I'm going to stick with this equation and finish it out. So a couple things I need to notice here are, I need to make note of, right, before I even begin the graph, a couple things I'm going to note. Note that your y is less than. So that means I'm going to be shading down whenever I get my graph, okay? The other thing I'm going to note is that it's not equal to. So that means my graph is going to be dashed, all right? So the last thing I need to be thinking about is what is my m, right? So my m, all right, is a negative. Well, a lot of people want to say, well, there's no number there. Well, yeah, there is. Look at it and go, how many x's are in front of you? Like literally, how many x's do you visually see? And you see 1, all right? So there's a reason you don't have to put a number in front of the x because there's visually 1 there. I don't need to algebraically, abstractly tell you that there's a 2 there. That's the reason we would put a 2 there in the first place. I suppose they're writing 2 x's. It's much more easier once you start giving me more and more x's just to put the number that there are. So the reason I don't need to put 1 in front of that is because I can look at that and go, there's 1 x there on the paper. So my slope is the number, the coefficient of x. So currently it's negative. It's not just negative, it's negative 1. Well, that's a little bit of an issue right now because slope is not one number. Slope is a ratio. It's a fraction. So you got to fill in a numerator and a denominator. Well, every integer on the planet Earth can be written over 1. Okay, so you have it, there it is. If you don't have, okay, a denominator, it's always 1. That's what you need to know. All right, so we have my m, so now I'm ready to rock and roll. I'm ready to go. So I go back to my equation and get my starting point, which is the y-intercept at negative 2. So before I move on here, okay, that's an open circle, okay, at negative 2, and then I go to my next point. So I go up 1, or down 1, okay, so negatives are going to be down. This is positive, it goes right. So again, down, the top number is rise, which is up or down. So I'm going to go down 1 value, and then I'm going to go to the right 1 value, open circle. So I'm going to do that for a couple points, right? So I get a couple points here, down 1 over 1. Okay, now, at this point, don't be the person who then goes to the other equation. Finish off one equation at a time. You're hurting yourself by trying to move to another equation. So draw your dashed line in now. Okay, so I'm following back into my little things that I have here because I'm thinking before I do it. I'm modeling what I'm going to have before I actually do it. People who skip things are the people who get things wrong. So do your little model piece here, right? You're shading down, put a little down arrow for your shading. All right, so here we go. So now I draw my dashed line coming down through. So dash line, dash line, dash line, dash line, there it is. And then I have my remembering that I'm shading down. So for this one, then I go ahead and I just simply shade below. So here we go, shading below. Okay, so there we go, shading below. There it is. Now, after I'm done that one, now I will finally move to the second one, okay? So these things are going to take time. There's no avoiding it. They're just simply going to take time. So now I go to the second one, and now I go ahead and I convert this one too. So now this one, okay, negative 3x minus 4y is less than or equal to negative 20. So now, how can you save yourself time? The way you can save yourself time is if you knew the conversion formula, right? And the conversion formula states that is the opposite of this, okay, the opposite of a divided by b. So this is going to be y. So why do I switch it to greater than? Because remember I talked about that if my y in the problem is negative, okay, this sign always flips. You always flip it. So if I'm using the conversion formula, you have to check y. If it's negative, flip it, the inequality for using the conversion formula. So then we just go ahead and do it. So negative 3 divided by negative 4x plus negative 20 divided by negative 4. And then from there, you just go ahead and simplify. So this is y is greater than or equal to. So negative over negative makes that positive 3/4 x. Negative over negative makes that positive 5, okay? So I've got this equation, y is greater than or equal to 3/4 x plus 5. So again, I'm going to model what I'm going to have before I have it. I'm going to visualize what I should be having. what I'm going to have here, okay, so I'm going to graph this one in red, is I should be shading above the line. I'm actually going to have a solid line this time, okay, because it's equal to. So the last thing I'm going to get is my slope. My slope, okay, is going to be 3/4. So that means positive 3 is up 3, okay, and positive x, right, the 4 is a positive x value, is to the right 4. So I like to put the arrows there. Everything now I have visualized. So now it's just a matter of going to my starting point, which is at positive 5, and I close my circle. I just put a dot, right? So I'm going to go up 3, up 1, 2, 3, over 1, 2, 3, 4, and put a dot there, right? So now at this point, I do have enough that I need to graph the line, but I'm just going to show you something here, is that if I follow this pattern back, which we go down 3, and to the left 4, that means I can get some points over here if I just follow that pattern. So down 1, 2, 3, okay, over 1, oop, down 3, 1, 2, 3, over 4, 1, 2, 3, 4. So boop, there we go. So now I get to connect those with a solid line. So now I connect them with a solid line. There it is, solid line drawn. And then what I'm going to make sure of is that I'm shading above. So here we go. I'm going to go ahead and now shade above the line. So when I shade above the line, here we go. All right. So shading, 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 shading. Now, systems, right? So let's talk about this idea of systems. All right. And when systems means you must have points or solutions, okay, that satisfy both inequalities. Well, I did a dual shading here, and if you take a note here, all right, one thing that I'm going to point out to you is this, is that where is there dual shading? So if you have to have a system that has a solution that works for both, that means you must have the area in which shading exists for both. And that shading exists for both right here, okay? So this piece right here, okay, is the place where shading existed for both. So what I'm going to do very quickly is I'm going to show you, I'm going to get rid of this shading area I'm getting rid of. And the reason I'm getting rid of this shaded area is because it is not a solution to this one. So this line tells me I have to be below it, so it can't be up here because that is a greater than it. So I'm going to get rid of that. So there's this information is gone. Okay, shading that, getting rid of that shading piece. And then down here, likewise, this information is no good, okay, because it is not a dual shaded area. So I'm getting rid of it, so I'm erasing it, okay? So there we go. There is my final solution. The solution is this area right here is where all my shading should exist right in here, okay? So if you're on a test, one of the things you just gotta be careful of who your teacher is, if they want you to erase all of it and just leave that shaded area, or if they just want you to darken in the shaded area, okay? So we now move forward. Okay, so remember the important piece here is if you're going to do the dual shading, you're just looking for it overlaps, and then you're going to erase the information that is not where it's double shaded. Okay, and you'll just leave the double shaded area. Now, A. So plot one point that represents a solution to the system of inequalities. Okay, so I want to plot one point, and I'm going to label that coordinate. So I'm going to get rid of this really quick just so I can see it. So I want to plot a point. So basically plot a point that works. So go to the dual shaded region, plot a point. So there's a point right there. So notice that the coordinates of that point are going to be -9, all right, 2. So there is a solution to my system. So if someone asks you for a solution, go to the dual shaded area, pluck a point from there, and give me the coordinates. And that is now a solution. Now it's not the only solution. There's an infinite amount of solutions. Just to prove something to you that a lot of people don't do, you don't have to pick a whole pair coordinate pair. You could pick, okay, something right in the middle there, all right? But the problem is, is now you have to tell me what that point is. Well, that point, okay, would have been -7.5, comma, 1.5, all right? So you can use that. So I just wanted to throw decimals in there so that you really understand that there's an infinite amount of answers that you really have to pick from. Just don't mess it up by picking from a point that's not in the shaded region, all right? So where does the solution of the system of inequalities exist? It exists in the dual shaded region. Okay, dual, the double shaded region, right? If you want a different word. Okay, it's the dual shaded region, the double shaded region. All right, so we're only dealing with a system of 2 equations. If I had a system of 3 equations, I would be looking for the place that has the triple shaded region. So every line I have means how many times I must shade in a particular region. So if I have 3 equations, I must have a region that is shaded 3 times. If I have 4 equations, I must have a region that is shaded 4 times. If I don't satisfy those requirements, then there would be no solution. All right. So next thing I have for you is the point 16 negative 7 a solution to the system? How about negative 4, 0, right? So here we go. I take a look at 16 negative 7. I go, wait a minute. I don't got a 16 on my graph. What am I going to do now? All right. Well, it's not that bad, so don't panic. All you do is you go back to what you did when you had regular systems, when you wanted to verify that if a point satisfied a system. Okay. So if it's not on your graph and you can't see it from the visual aid you drew, all right, all you simply need to do, okay, is plug the point in and make sure that it satisfies both system of equations. So another way to doing this is now the algebraic piece, okay? The algebraic piece is working with numbers. So this is what we do. You take both systems. So you get x plus y is less than negative 2, and you get 3x minus 4y is less than or equal to negative 20. And all you're simply going to do into those 2 equations is you're going to plug your points in. So this is x, this is y. Coordinate pairs come x comma y. My equations, haha, look at that. They're made up of x's and y's. So I plug those values in. So here we go. This is 16 plus negative 7. And is that less than negative 2? So 16 plus negative 7 is good old 9. Is 9 less than negative 2? Well, no, that is false. Well, guess what? All it takes for me to stop this problem and say that that point is not a solution is one false statement. Okay, one false statement would mean that 16 negative 7, okay, is not a solution to your system. All right, so I hope that makes sense to you and hopes that you're following that. But the point 16 negative 7 is not a solution to our inequality. Okay. So it doesn't mean that it doesn't work for at least one of them, but the point 16 negative 7 is not going to work for this particular problem. Okay, so I hope that helps and I hope you understand what we're doing here. Now let's check that point negative 4, 0. All right, so negative 4, 0. Okay, let's do the same thing. Well, negative 4, 0. I'm not going to plug it in. Well, why am I not going to plug it in, right? So what do you mean? You just plugged in the other one. Well, that one I can go up to my graph and I can plot that point. So if you can plot the point in your region, so there's the point negative 4, 0. Negative 4, 0 is not in the dual shaded region, so therefore this is not a solution, okay? So I hope you're starting to see that you can do, if you don't have it on your graph, if it's not visually there, you plug the point in, it better satisfy the systems, okay? So it better satisfy those inequalities. If it doesn't satisfy those inequalities, then you're in trouble, okay? So just to show you a point that would work, right? What happens if I change that 16 just simply to a negative 16, all right? So let's plug that in, I get negative 16. So that alters, okay, this 9, okay, becomes good old negative 23. Well, is negative 23 less than negative 2? And that changes that false statement now to a true statement, all right? So now let's go to another one. Let's go to the other one because you got to do both equations. So this is now 3 times negative 16 minus 4 times negative 7. And you're asking yourself, is that less than or equal to negative 20? Well, 3 times negative 16 is negative 48. Negative 7 times negative 4 is negative 28, or is positive 28, my bad, is less than or equal to negative 20. And then I take a look at that and I get 20, or negative 20 is less than or equal to negative 20. Now you're inclined to say that that's not true, but the problem is this little equality goes ahead and says, yeah, it's okay, it's true. So now what I'm just showing you is that if something is a solution, you're going to have a dual true statements, okay? If it's not a solution, then you're going to get one false statement, okay? And all you need is one false statement. You could get 2 false statements, but all you need is one to conclude that it would not be a solution. So I hope you see the difference between not a solution, solving it using the equations, and now you see what happens if it were a solution, all right? So I just want to give you those examples. All right, so on to the next problem. So we'll do some more of these graphing. So here we go. We're on this problem. Oh, hey, one equation is in already slope intercept form. I don't even got to convert it. So guess what? I'm going to take that equation. I'm going to graph it immediately. Couple things I'm going to note though is that it's down. It is a less than, so I'm shading down. The next thing I'm going to note is it's going to be a dashed line because it's an inequality. And then I'm going to take my m, and my m is going to be, well, oh wait a minute, I have a negative out front. Well, where does that negative go? Okay, I suggest this. Take your negative and give it to the 2. You only have one negative, so it's only going to one of those numbers. It cannot go to both of them. Pick one to place it with. I'm going to place it with the 2. So a negative 2 is my rise, which means I now go down 2. The 5 will be positive to the right 5. So I have my slope. So go to my starting point, which is negative 3, found from the equation. And I put a solid dot. Ooh, be careful, right? Not a solid dot. I'm using a good old open circle because it's not equal to. So open circle. Now I go down 2, 1, 2, over 1, 2, 3, 4, 5. There we go. So now I go down 1, 2, over 1, 2, 3, 4, 5. Oh, it's off my graph, so that's no point. Okay, so I'm going to go back to my starting point, and I'm just going to reverse the directions that I just did. So instead of going down, I'll go up 2, and then to the left. 1, 2, 3, 4, 5. Open circle. So what I now am going to do is I'm actually going to connect my dots. You'd be silly to move forward, okay? Because what I'm now about to do, okay, when I connect my dash through here with systems, all right, my dash line, I'm about to cut my graph into 2 separate regions. So right now I know I should be shading down. So I'm going to go ahead and shade down. All right, and the importance of shading down, okay, is I now know that there is no way on the planet Earth you should ever get an answer, no matter what line I have, that is above this line. You should never pick an area that is above this line as a solution. It's not going to happen because this right here is already limited. It cut this whole half off. So you are basically going to draw another line through here somehow, and you're going to then cut this in half, all right? So basically, you are going to be shading somewhere in the here if it exists, all right? So here we go. So now what we have is we've got this other equation. Well, this other equation is not in slope-intercept form, so we must do that. So what I'm going to do again is I'm going to utilize the conversion formula, which means I take the opposite of the a, so this is going to be y, and this is going to be stay greater than. The symbol will stay that way. So this symbol will stay greater than because the y is positive, so I don't need to flip it, so y is greater than or equal to. Okay, and it's going to be the opposite of 4, which is negative 4, divided by the b, which is the coefficient of y. Throw an x with it, okay, and it's a plus, and I'm going to take 6, and I'm going to divide it by the coefficient of y, which is 3. All right, so then I get y is greater than or equal to negative 4/3 x plus 2. So I just clean it up, and then here we go. So a couple of things. I have a greater than. If I have a greater than, I'm going to mark off here, okay, then I'm going to shade up, okay, I'm going to have a solid line, and the last bit I'm going to do is always do my slope. So my slope is negative 4 over 3. So it is negative 4, which is a down 4 over 3, which means it's a positive 3, so it's to the right 3. And now that I have my information I need, I go to my starting point. My starting point is found from the equation. The y-intercept is positive 2, and it is equal to, so solid line. So I'm going to go down 4 and to the right 3. So down 1, 2, 3, 4, 1, 2, 3. Plot a point, okay? Down 1, 2, 3, 4 over 1, 2, 3. Plot a point, okay? And then I'm going to go and I'm going to draw my line. So now that I have that, I go ahead and I draw my line connecting these points. Okay, and now what I have is I'm going to come back, all right, and I'm going to shade what this region would be. So this one is above the line, so I'm going to shade up here, right? So I shade, okay, shading along this line, I'm shading in the upper parts. So there we go. So now, what you're looking for is a region where you should have dual shading. And the region where I have dual shading is this tiny little spot right down here. This is my dual shading. So I'm just making it a different color so you see the green is where my dual shaded region is. All right. So what that allows me to do, okay, is that now allows me to go ahead and get rid of these other shaded pieces. Okay, so I'm just going to get rid of all this shading, all right, because that is not a solution. It's not a dual shaded area. So I'm erasing anywhere, okay, that doesn't have a dual shaded region, and I'm leaving only the spot, okay, that has the double shaded area. So if I were to ask you, what is a solution to my inequality? Tell me a point that's a solution. You go to here and you plot a point right in there. Okay, so you plot a point in there, and there's my point, okay? And then I get the coordinates of that point. So the coordinates of that point are 9, comma, -8. There is one solution to my inequality. All right, so let's do another example. Okay, so I'm going to do this example a little bit different, all right, than the other one. So I'm not a person who does shading when I do these. So I'm going to show this and demonstrate this another way, just because I'm a person who doesn't like to do the shading, because me personally, I was always taught when I was growing up that if you have shading on a graph, that means that you are representing a solution. But all teachers are different, and you just have to pay attention to what your teacher is cool with. So ask your teacher, are they cool with leaving all shading on there and just you darkening in the dual shaded area? And if they say yes, you're good to go. If you are one of my students, the answer to that is going to be no. So I am sorry, but that is just me being a stickler. So I do apologize, but it's the way it is. So here we go. All right, so here we have two equations. So neither of them are in slope-intercept form. So what I'm going to do is I'm going to convert them. So I will show these ones this time utilizing, okay, the properties of solving equations. So here we go. So I need to use the opposite. So this is a positive, so the addition opposites. So there we go. That takes care of that. What I do to one side, I must do to the other side. So now I am left with this. Negative 8y is less than negative 4x minus 16. And now I must divide by negative 8, divide by negative 8, divide by negative 8. And what the very first thing I'm going to do is I'm going to flip that inequality, because I wrote a negative in a denominator. You write the negative in that denominator, or a multiplier, you are going to flip that inequality. Flip it, and I get y is greater than 4, negative 4 over negative 8 becomes 1/2 x. Negative 16 over negative 8 becomes positive 2. All right, so there's my first equation. Now, I am not moving to the second one. I'm going to graph this equation. So I'm going to mark my things I have that I'm shading up, okay? That is going to be a dashed line, and then my slope is m equals up 1, right 2. All right, so those are the mental things. So go to my starting point. I'm going to put an open circle at 2. I'm going to go up 1 to the right 2, open circle, up 1 to the right 2, open circle, up 1 to the right 2, open circle. And then I'm just going to reverse that. So go down 1 to the left 2 from my starting point, down 1 to the left 2, okay? And then what I'm going to do is I'm going to finish this off. I'm not going to stop here, okay? I'm going to finish this off. So graph this line through, okay? Don't be the person who starts putting points all over the place and then you don't connect the right points and get this long. That would be silly. That would be ridiculous. So now what I'm going to do is, I'm a person, I like to put the up arrow, all right? Because I don't like all the shading. I'm just going to put a little up arrow here, a little up arrow there. All right, so basically what I've just said to myself is, there is no way that there should be any shading that I ever do down here. Just not going to happen. Basically, when I have my system come through, it's going to cut this area into 2. And all I need to do is my next arrow is literally going to point to me the area that I shade, because I know that the answer is up here. So my next time that I put I put a line through, my arrow will tell me directly what region to shade. All right. So here we go, and I'll show you what I mean by that. So I'm going to convert this equation now, and this equation is negative 10x plus 20y is less than negative 120. So this time I'm going to use the conversion formula again, okay? So the opposite of this, so y is positive, so it stays less than. So it's going to be 10x, okay? And then it's going to be divided by 20, so this first value is always being divided by this one, so that's easy enough. And then the second time we do this, I'm going to have negative 120, okay, divided by this value again, which is just 20. So then it's just a matter of simplifying. So y is less than 1/2 x minus 6. So here we go. So a couple of things I'm going to note is that I'm shading down. I have a dashed line, and my slope is going to be up 1 to the right 2. Okay? So here we go. Go ahead and shading that in there. So what I get is I get this -6. So here we go. Open circle at -6, and then I go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. Now I reverse it, go down 1 to the left 2. So I throw my dashed line in here. Okay. And then I'm going to throw my tick arrow in here. Wait a minute. I knew by the first line that I graphed that my solution, if I had one, should have been up here. Keyword that I just said there. If I had one, my first line dictated that the answer should have been up here. This is telling me to go the opposite way. Well, that's not cool, because if I go the opposite way, it's not getting me to this region. So therefore, am I ever going to have a dual shaded area? And the answer to that is absolutely not. And the reason for that is that these lines are what we call parallel. How do you know they're parallel via algebraic equation? Well, the rate of change is 1/2 here, and the rate of change here is 1/2. Be very, very careful to claim that something doesn't have a solution before you do without looking at the equation. Just because they don't intersect on the graph or anything like that doesn't necessarily mean that they're parallel. It has to have the same slope. So this particular solution, okay, is going to be that no solution. All right, so notice that that no solution has crept back in again, all right, for the idea of parallel. Now, just because they're parallel doesn't mean that they're no solution, okay? Because I could change this equation one tiny way, and all of a sudden, I have solutions. So these arrows were going down. If I had shaded up, okay, if I had had greater than, then I definitely would have had a dual shaded region that would have just been above the red line, okay? So I want you to fully understand that just because inequalities are parallel does not necessarily mean that the answer is no solution. Your solutions on inequalities come from your dual shaded region. The reason that this problem has no solution is because there is no way that my two inequalities will ever produce an area of a shaded region that overlaps, okay? So moving forward. So if you're now one of my students, I have some review problems that I'd like you to do. Otherwise, if you're just a person who is watching this video, well, here's some good review problems that you probably should probably brush up on anyway. There's some inequality, absolute values, solving systems, and also we have these the ones like we did today. So we're now graphing the systems of inequalities. So you have 3 of those for some practice, being that this is the first video on that. So I hope this helps with whatever it is that you're doing, and yeah, let me know what you think, if you liked the video or not, and if you liked it and you want more videos, and I do take video requests, so please feel free to send me maybe an equation. Maybe I didn't do an equation that or an inequality that your teacher has provided you with, and you'd like to see it because you really don't understand it. Just send the video, and I'm happy to make a video on it, all right? And the video that I make for requests will not be nowhere near as long as my teaching video for notes. So those videos are normally between 5 to 10 minutes. Obviously, these are a little bit longer because they are actual lesson videos.